Okay, let's do another example here of conservation of momentum and collision. So let's say that we have a block here, and the block has mass m, and we shoot it with a little small object here, mass little m. So let's say that mass little m is going to be 20 grams. It's initially moving with some velocity v naught, and let's say that's 300 meters per second. So this is a bullet, and let's say that mass m is going to be 3.25 kilograms. So what's going to happen is the bullet is going to hit and embed itself into the bigger mass. Now this mass is going to start sliding with some velocity v with a small mass inside of it. And so we want to look at this as a momentum problem, collision. So how do we solve the problem? Well, we know that momentum is conserved quantity because we know that the change in momentum is integral f dt, okay? And so for every force, an equal and opposite force. So if one thing has a force on it, it has a force opposite that on something else. So that means that if one thing gains momentum, another thing loses momentum. So we have conservation of momentum. In our problem right here, all the momentum was originally right there, and then afterwards, it's all combined right here. So this is the final momentum. So we know that the initial momentum has to equal the final momentum. And so the initial momentum is going to be the mv naught. At the end, they're stuck together, so m plus m times the v final. Okay. And so we just do a little bit of algebra. We see that the final velocity is mv naught over m plus m. And so if we plug in our numbers right here, that gives us 1.83 meters per second. Okay. Well, let's consider the possibility that the bullet actually goes through the object. So now what's going to happen is we have a v naught right here, and we're going to say the v naught is still 300 meters per second, but it has a v final afterwards. Let's say the final velocity is 185 meters per second. And so now what's going to happen is it's going to go through, and we're going to assume as it goes through, it just pushes stuff, to the side, out of the way, and does not change the mass of the original block. And so so that's what we're going to do. We're going to assume that it does not change the mass of the original block. And so that means that initial momentum is still going to equal final momentum. The initial momentum is mv naught, but the final momentum is mv final plus mass of the block times the velocity of the block. So we do a little algebra here, and we find that this is equal to little m v naught minus v final divided by big M. Okay, all the mass is the same, so we're going to plug in our numbers, and we find in this case the block is moving 0.708 meters per second. Okay, because some of the momentum stayed with this object right here. And in fact, that's actually an interesting idea that certain race cars came up with, and that is when, for example, you see like an Indy car in a crash, and parts of the car go everywhere, and they're actually kind of designed to self-destruct like that, because that carries a lot of the energy momentum away from the driver. So now let's make it a little bit more complicated. So we're going to have our block here, mass m. We got the bullet coming in, some v naught. V naught is still going to be 300 meters per second. Okay, the mass of the little object is still going to be 20 grams. The mass of the block is still going to be 3.25 kilograms. The bullet's going to go through, it's going to come out with some final velocity, and we're going to say the final velocity is still 185 meters per second. Everything looks the same, except instead of the bullet just pushing stuff out of the way, it threw a whole bunch of other stuff out. So as the bullet went through the block, it pushed a bunch of stuff out in front of it. So we're going to say the mass of that stuff is going to be 500 grams, and the velocity of the stuff coming out is going to be 35 meters per second. Okay, so what does that do for us? Well, that means initial momentum equals final momentum. So the initial momentum is still mv naught. The final momentum is going to be mv final. Okay, it's also going to be the mass of the stuff times the velocity of the stuff, and it's going to be the mass of the block, but the block has now lost some mass because some of the stuff got blown out, times its final velocity. So the velocity, after you do some algebra here, is going to be mv naught minus v minus ms vs divided by m minus ms. Okay, so you plug in all the numbers and you get a minus 5.53 meters per second. And so it's like, oh, what does that mean? Well, what that means is that as the bullet came through, when it blew all the stuff out, this recoiled back that way as the bullet and the stuff went on through. And so that, can that happen? And the answer is, well, yeah, it actually can happen. That you can actually shoot something. You can shoot something and you know, like a bottle of water or something, and the bullet, if it goes in right and comes out and blows enough water out, the bottle of water can recoil back in the direction the bullet came. And so that's really confusing to a lot of people, you know, that would see something like that, and it's like, you know, they look at it and they're like amateurs, and they want to sort of explain here. For example, you know, they say, aha, you know, President Kennedy's head went in one direction, so the bullet must have come from the other direction. Well, they're not taking into account that actually stuff came out of his head when the bullet went through, and so that changes the direction that the head recoiled. And so that means there's not really a necessary for a second shooter in there to explain the observations. So that's an application here. And so and again, I did this example of a recoil like this a bunch of years ago during the height of the Iraqi war, and I actually had a veteran that was a combat medic coming back and was taking physics to go to medical school, and he said that really explains a lot of the combat injuries that he saw when he started realizing the recoil could be opposite the direction the bullet came from, or back opposite the direction the bullet was traveling, back in the direction the bullet came from. So